Yes. Everybody's talking about the cost of software. The need to reduce, to manage software, especially in this economy. The question is how? How do you manage that? Well, in this session, what we're going to try to do is show you how you can think about software in terms of cost, what's called cost-oriented development. And this is not just about the development. It's about your entire application lifecycle. And we're going to show you some tools that you can use to help manage and reduce that cost for your applications. My name is Shai Cohen. I'm the CEO of Cloud Value. This is Alon.
I am the CTO of Cloud Value.
And welcome to DPA 307, Cost-Oriented Development. I'm going to start with a statement. Not accounting for the cost implications of your architecture, design, and implementation will result in lower cost efficiency. And we're going to spend the next 75 minutes showing you that and giving you the tools to deal with that. And so hopefully at the end, you'll agree with us and have the tools to do something about it. Oh,
Shai,
demo?
may I see your wallet, please?
What?
Your wallet, please.
Okay. Surprise demo? What do you do?
Yeah, it's a new demo. You don't know about it.
What's going on?
I see several money.
What? What?
Oh,
What are
sorry.
you doing?
More.
What
So
are
you have
you
more
doing?
cards.
Yeah.
You know what? Take.
Yeah, I better get that back. What was this about?
I'm making better use of your money instead of wasting it on bad code.
Okay. All right. I think you made a point. I want my money back. No, you can keep it. It's okay. All right. So when we talk about the cost of software, we know that there are the two parts, right? This is the iceberg thing, right? We know that the cost of acquisition, the hardware, the software, is about 10%, a small amount of what the software really costs. Let me just do that so I don't have to. Ah, fantastic. And the real money is in the operating costs. Right? All those things that are like the hidden cost of software. That's the thing that lasts the longest.
Yeah, but Shai, I think that this is what the cloud is all about.
That's right. That's right. That's actually very correct. Very correct, because I have a slide for this. The cloud computing does address many of those things, but at the same, or completely eliminates them or lower them, but at the same time, it also highlights other things, especially runtime costs. And this is really good. Sorry. And this is really good because then we can really, when we look at the cloud model, we can really focus on the cost aspects, and it comes to the front, the cost aspects of your software. So we're going to use cloud analogies, and we're going to use cloud computing as an example, or the kind of examples here as we go through. But what we're talking about is not just for cloud computing. It applies to any software that you write, which is just easier to see with cloud computing, but it is everywhere. And so the challenge when you go to the cloud is that the cloud has this wonderful pay-per-use consumption model. You only pay for what you're using, not for capacity. That could result in huge cost savings, and it is, but it could also spell trouble if the cost is not managed properly. And I'm talking both about the cost of development and the cost while you're running, the runtime costs. And the way you handle that is by creating a cost management strategy. And that's what we're going to talk about next, a strategy for cost management that helps you understand the cost of your application, that helps you architect and design solutions with cost in mind, and help you implement your solutions efficiently. And so what you really need to be able to do that is cost insight. When you look at the life cycle of your applications, you see I put cost in the middle there. Right? Cost is important at every stage of the application lifecycle. It's not just something that you think about at the end when we go to ops. And as I said before, it's important for every single application type. What we're going to do in this talk is we're going to use this lifecycle image and analogy to go through and address cost at every single one of those stages. We're going to focus primarily on the beginning because this is more of a, hopefully, but this is the architecture track, so we're going to focus more on capturing requirements and architecture design. And then we are going to cover the implementation, testing, and operations because these are things that architects need to be very well aware of and able to influence in their organizations. That's my belief. What we're going to do is we're going to use this strategy, and if you've done math in school, like second grade math teacher probably showed you that. This is a very known way or methodology of approaching problems. First, we understand the problem, then we plan how we're going to address the problem, then we actually address it, and then at the end, we review, we reflect. We both look at what we've done and make sure that we did solve the problem correctly. But at the same time, we also look at what we've done, think about it more holistically and say, can this be applied elsewhere? Did we learn anything significant here? So that's going to be our methodology for how we deal with those things.
Okay, so we start with cost-oriented requirements. Requirement is the first stage when you deal with building new software product. There are, got it. There are three elements for requirement. There is the functional requirements, the non-functional requirements, and constraints. And all of these elements and each of your requirements has a huge impact on construction expenses and also on operational expenses. And again, we'll use the same method that Shai just talked about. For each requirement, we need to cost analyze it. So you not just need to understand the requirements, but you also need to understand the cost implication of these requirements. Then you need to understand and discuss this implication, make a report, and talk with the stakeholders about all your findings. So for functional requirements are those requirements that you actually need to implement in order to have the solution. So again, you need to look how to implement the requirements in a wise way, especially regarding cost. Non-functional requirements are those requirements that are more interesting for us, the architects. Because non-functional requirements deal with the structure of the solution and will have a huge impact on the quality attributes of your application. And one of the main quality attributes is reduction of operational expenses. Engineering is about making compromises, and architecture is engineering discipline is about building the product and making the right compromises. And as I said, cost is one of the main quality attributes that we need to deal with. And again, we need to understand each of the non-functional requirements, and you need to plan how to implement them wise. And we are going to see next, in a few slides next, we're going to see some ways and some patterns that can help us to fulfill those non-functional requirements, but also to reduce the cost. Let's take some examples. Suppose I care about latency.
All right, so let's say I care about cost.
So if I care about latency, I want to my application to be very responsive. I don't care about creating more instances. If we talk about the cloud, I can spawn more instances and be much more responsive.
Right, but as opposed to spinning up more instances or getting beefier computers or whatever, making a large web farm, whatever that is, I care about cost. So if cost is the first thing in mind, then what I would probably do is put requests on a queue and then don't have to deal with large spikes or with a large load. I can use the queue to balance that load, and so I can basically use smaller compute instances, whatever that is, in the cloud on-premises, to process those requests.
So again, we do some compromises, and we decide what is the quality attributes that we want to fulfill, and then we can decide whether we pay more and gets more, or this is the part in the application that we allow to that we can allow to have less better quality attributes, but we can reduce the cost.
So,
what about constraints?
So constraints are interesting things. Constraints comes from all sorts of places, right? They could be competitive. My competition is doing this. I got to do this or I'm not in the game. They could be regulatory. I have to store my information in a certain geographic locality, right? They could come from all sorts of places. And those constraints can affect cost in a drastic way, whether that's computational, storage, or networking aspects of my costs. All of them can be impacted heavily by those constraints. And so when I want to put the cost on those things that I can't avoid, well, the first thing I need to understand all of my constraints. Where am I? Where do I live? What are the things I need to deal with? And then I'm going to plan a way to deal with those constraints. As I document my constraints and I put the plan on how to address them and the money, the dollar amount or the whatever euro amount for how to deal with those things, this is a great spot to stop and say, is this product viable? Can we do this given our constraints? Are we going to be able to do this in a cost-effective manner? Because sometimes you'll get to that point and it'll be end game, right? Sorry, we can't do this. You can come back and do something I'm going to talk to you about in a second, but at this point, if you say, this is my budget and this is what I need to accomplish, it doesn't fit.
Yeah, but this is a good time to go back to your stakeholders and tell them
that's right. Don't steal my
you
thunder.
might-
I think I got it on the next slide.
that you might want to change.
That's right. That's
these
correct.
constraints and also other requirements.
That's right. That's right. So cost orientation is not just about lowering costs. It's really about focusing on value. How can I maximize, take my resources and maximize them? Cost limits are constraints. And like Alon said, you can go and you can negotiate constraints, right? You can go back to my, tell them, look, good, look, go build this for me, here's your budget. And you can come back to me and tell me, we can't do this under this budget. We either need to do less or increase the budget, right? So constraints are things that can be negotiated, that can be managed, but cost orientation is about a quality attribute, right? It is about maximizing value, and that's a quality attribute, not a constraint. So don't think about cost orientation in terms of constraints. Think about this in terms of quality.
So to sum up the requirement stage, you need to understand your functional requirements, not just for building the software, but also to maintain the cost of the software. You also need to understand the non-functional requirements, because these are the requirements that will affect your architecture the most. And of course, as we said, we have to look at your constraints, and you have to communicate your findings with your stakeholders.
Okay, so we're done with the requirement stage. Let's go talk about architecture and design. When you go to talk about the architecture, before we dive into the architecture itself, we need to understand the application. Okay? What are the application's component utilization characteristics? In other words, if you look at any app in the world, it basically has those 4 components. There might be some others, but it has these basic 4 components. It has storage, it has CPU, it has memory, and it has communication, networking. Right? And so let's break this down and look at those aspects one by one and try to understand how we deal with those.
For example, is your application CPU bound? What is the load characteristics of your application?
Right. And I put up here the cost model for Windows Azure right now. And it's very, very similar to the Amazon one. And this is just a reflection of what goes on premises. Because on premises, yes, you're paying for compute too. Right? You just sometimes don't see that. And that's that iceberg the hidden part of that iceberg that you don't see. But this, as again, cloud computing brings it to the forefront, to the front. And if you look at that, then you can go and say, what kind of computer do I need? Do you need a computer with a lot of memory? Do I need a computer with a little bit less memory? What's the bandwidth requirements that I have? Right? That's the message here when you look at your application from a computational requirement.
And the same goes with storage. What is the kind of that data that I need to store, for how long, and so on?
Right, and again, this just bringing up the numbers from Azure, but again, because it's hard for me to tell you what is going to be on-prem for you, but these are, again, the ways that you can think about the cost implications of the storage requirements of your application.
Your communication requirements, whether the data will come from your server to the client or the other way, what's kind of data, what is the size of data, do you do chatty or chunky interfaces, and so on.
And really those traffic patterns that you have, whether they're system-generated or user-generated, are going to affect your networking costs. So again, sample from Azure, just bringing it forward and telling you what it is. But you're paying for network in a data center as well. So when you look at everything, and this is a really, really simplified example of the report that you need to produce.
Yeah, the last report that you produced was like 100 pages. So
yeah,
this is
so
very
I can't fit 100 pages on this slide. We tried, but the font was really, really small.
Yeah.
So this is kind of a template for how you can think about the costs, right, of an application in terms of the compute. And you need to analyze that. What are the storage requirements? Analyze that. Communication. You can start thinking about throttling strategies and elasticity strategies, and how are you going to enhance that. By the way, all the slides are available later. If they're available now, actually. So if you want to get this thing as a template, you can download them from there. But before you move on, back, thank you. The bottom line is that at the end of the day, you can go and tell the stakeholders, look, this is how much this application is going to cost as a baseline. And this is how much it's going to cost me per user, per month, or whatever the metric is that you want to use. Right? You need to be able, after this analysis, you need to be able to go and give at least a rough estimate, because that's the first question that management asks, is how much is it going to cost me? Apparently, it cost me my wallet.
Yeah, probably. So after we finish the first stage, which was understanding the requirements and analyze them, we can move on to the architecture part.
So that's cost-oriented architecture.
Right.
Okay.
So, for example, let's take SOA, service-oriented architecture, something that probably all of you are doing. So, for example, we decided that our application is built with these different services that talk one with each other, and we want to deploy them into the cloud. The straightforward way will be to deploy and run each of our service as a worker or web role.
That's right. But what we need to do is stop here and not mix the architecture with our deployment strategy. Okay? Because if, for example, service B and D have the same scale requirements, they need to scale up and down together, and they need to talk to each other, they talk to each other all the time, why not put them together in a single role? And I can say, with this particular example, 40% of my runtime costs, 40% of my runtime costs by doing that. Just think a little bit differently. And so sometimes the standard solutions, or the way that we used to think about things, is not necessarily the best one or the optimal one for a particular case.
For example, another example, we have an application. This is a very common architecture. We have a master, a service that gets all the requests, and it spawn or queue work to other slaves. And again, as you can see here, we decided to deploy each of our service to a different role.
Right. And another different way to think about this, two different ways to think about this, are changing it to maybe we do it peer-to-peer, and we remove that master. Or maybe we have a non-dedicated master. So if via some voting, and there are actually simpler mechanisms, that the peers can decide who's going to divide the work and who's going to do the work, then maybe you can do that and again, save those costs. So if you look at ways to optimize compute resources, we have a whole list here on the slide. We have a lot of slides like that have a lot of ideas and things on them. We're not going to be able to discuss each and every one of those at the appropriate length that we want to. But as I said, these slides are available later, and we're going to be here. You can come and talk to us if anything there spikes your interest. But there are many ways in which you can optimize your compute resources, whether that's combining services like we talked about, creating things like compute roles, and very interesting, the second bullet there is mining the cost boundary. Now, if you're deploying in the cloud, well, apparently they charge by the hour, but it's a wall clock hour, not running hour. So, for example, if you have something that is running from 1:45 to 2:15, that thing runs for 2 hours because it spanned 2 wall clock hours. So if you have something that's currently running and you're at the, you're okay, my load is done, and I'm at, only 15 minutes after the hour, keep it up. Keep it running. Don't take it off, because if you take it down, you're still paying for it. What if another spike comes? If you spin another thing, you're going to pay for another instance. Just keep it out there. Okay, so that's, for example, one of the strategies that you can take to reduce compute resources.
We are in the architectural stage, and one of the things that, as architects, we need to do is to architect our interfaces. And there are some known patterns like avoiding chatty interfaces, being chunky, but we have to think more. For example, look at this interface. I just want to get the user information. And if I don't know what the clients that call me wants, I can provide him everything. I can provide him even the avatar. But suppose the clients that call the server only need to have the username, ID, and email. Do I need to provide him all this information? And all this information it's not just transferring the data that you pay for, and then you pay for it. It's also to get the data from the database, and sometimes it's also to calculate and compute the data. So one way to solve it is to get the client ask, like using bitmap or something, what you really need. Another way is sometimes not to be just chunky, because if 90% of the time it just needs 2 fields, I can create small interface just for that. So we need to analyze the application to know the usage pattern, and then to create our interfaces.
Right. Actually, if you can go back 1 slide back.
Once.
Yeah. So, but one important point here is don't perform a natural act in the name of cost saving. Okay? Think, what is really going to be the cost implication of maintaining, of designing, developing, and long-term maintaining what it is that you're building? Is the saving really going to be that meaningful, compared to the other costs associated with software?
Now, it's not just about the interface. Interface is something that you design, you decide, but sometimes you use other technologies. Think about the cost of dataset, what you're moving, what you're transferring when you use dataset, and the same goes with entity framework or anything else that you use. You use a control, you download the control to the client. Does this control heavy? Okay, so you think about what you use and what is the implication about, what is the cost implication of this specific element.
So one example, I want to give you something like thinking out of the box a little bit, okay? So in our online cost tracking application, we have these charts where basically when you log into your account and you go and you look at what is my cost today, you see this chart, and this is the first version of the chart that we had. Now, by just choosing the right order of charts and loading tab content only when the tab is displayed, we managed to save a lot of money. So originally, with this design, we had about 2.1 charts per visit. That's how many we needed to generate. No, still on my thumb. Okay. Clicker.
Yeah.
There you go. I got the clicker, you're not getting it back. So, and this was because if you see, like, we had this order instances, hours, cost. Everybody always saw the instances because that's the first graph, and then immediately they click cost, right? So, but just switching things around and putting cost first, we actually managed to reduce the imprints that we're doing from 2.1 to 1.6. So now we're saving cost, but just doing something clever in the UI. Just not even clever, right? We didn't specify to the developer what the order of tabs should be, so we just put them in a certain order, and then we measured. And then we said,
we also give better service, because this
That's
is what they
true.
want to see.
That's true. That's absolutely true. So, switch this thing. Here's another interesting thing that you can do to save costs.
Okay. So, and actually, this is a very simple thing that you can do, and it might save you a lot of money. So
this is the bid now sample. It's kind of an Azure sample.
So what we can see here that actually you can't see because it's too small, but now what you can see here that this tool, which is something that we build and we build it as a part of Visual Studio, this tool can go through all your images, and it's in its very simple way, it can compress the image using a lossless algorithm, so you don't even lose the quality of the image, but you reduce the size of the image, which means that you save in your storage less information, and you also transfer less information to the client. Another way, which is the manual way, is to look at all of your images, and we calculate the cost of 100,000 download of this image, and you can choose an image, and here you can pick the right quality, and let me just enlarge it so we can see. So you can reduce the quality, and you can see here that you lose some information in the picture, but you can pick something that looks okay, and you save $5 for 100K downloads. And for a commerce site, it might be lots of saving, because people look at the catalog, they download. There are many people that goes to this site, they download the catalog, and you pay now much less. So this is a very simple way to save money.
There are many other ways that you could save money. Clever things like avoiding computation. For example, using the client CPU. I'm going to show you an example in a second. Or if you're deployed in the cloud, or even on whether that's a private or public cloud, or even if you're running your own VMs, choosing the appropriate VM size. And it could be different sizes for the different roles that you have, or different services that you want to spin up. But it could also be different sizes for the same role or same service that you want to have at different times. Other things like avoiding accessing storage and lowering computation costs by using storage and basically trading that off.
So there are many ways to optimize cost. Some of them are known ways that they are just the same ways that we optimize our application for performance, for memory, because if we reduce the amount of memory that our application uses, or if we get better performance, so we need less CPU power, we also save cost and save money. But there are some specific things that we need to think about, especially if we are running in the cloud. And these are the cloud resources that we are using. And we want to dive into these resources and show you some good patterns about them.
And I just want to make the point that, as I said, we're talking about cloud, but these things are the same. For example, if you're using SAP, or if you're using any of those systems, each one of those systems has its particular costs associated with it when you go and access that. And so we're going to show you some samples about cloud computing, because they're kind of ubiquitous. But if you have systems in your organizations that you're going to be charged for, or charged for the usage, these same techniques apply there as well. So the first example we're going to show it's actually a great one because it applies everywhere. It applies, it's not just about cloud. Is about offloading work to the client.
So for example, suppose I want to have a graph. One way to do it is to build the graph on the server, in the server side, and download the image to the client. Now think about thousands of clients that get into my server. I need to query the data, build a graph, and download this image. Instead of that, I can only download the data for the image, as you can see here. And using Ajax and using client side, I can create the graph from the information. So I use the client CPU. I transfer much less data, and I get even better results, better responsiveness. I get better quality attribute with less money.
Which is awesome. And if this wasn't clear, this is an example of a JavaScript chart control. So we're rendering the UI on the client, and all we're sending is bytes instead of kilobytes or megabytes down to the client to create those images. Oh, you're showing the Ajax?
Yeah.
Yeah.
Never mind.
It's all you.
So to sum up the architecture part, we have seen that we can use SOA service-oriented architecture, but we need to do it in a wise way. And using SOA does not mean that we deploy each of our service on its own. We can combine them. We can change the way that we think in order to reduce the amount of running instances. We talked about interfaces, how we can create effective interfaces. We need to understand the way that we talk with the clients. We need to understand what is the information that the client needs. And we need to measure the right things.
We're going to talk more about measurements going forward. So we talked about requirements, we talked about architecture and design, and we're going to spend the next few minutes talking, well, kind of the rest of the session, talking about the implementation, testing, and even operations aspects of your solution. So you're the code person.
Right.
Take a look at this and tell me if you see anything wrong.
Let's see. We call 10 times to send a message. We get a connection. We call. You know what? The only thing that bothers me here is this comment that tells me that we might have 10 concurrent service bus connections.
All right, so let me show the code behind this. Okay? All right. So here's the code for get connection.
Okay, so now I see that we create channel anytime that we call get connection.
Right.
We don't use some sort of connection pooling or something.
Factory patterns, yeah.
So I think that we might have a problem. Can you go back to the slide before?
Absolutely.
Whenever we call to get connection, the controller variable gets the new connection, and actually it seems like we lost the last variable, the last connection. But .NET is not deterministic. .NET will close this connection only on garbage collection.
That's right.
So actually, this comment is right. We might
It is
have,
right.
You know what? It's good that it's only 10 concurrent connection, because it could be 100.
Exactly, and the thing is that in this particular thing that we're using the Azure Service Bus, Windows App Fabric, or Windows Azure App Fabric Service Bus, it's a long name. We actually pay by the number of concurrent open connections. And so if you go over, this could be extremely expensive just by keeping those connections open.
So one way to solve this problem is to add this determinism. For example, we can use the using C# command to call the dispose, or we can manually close the connection. Or even better, we can reuse the same connection by just create some sort of factory patterns or having a connection pool, so we will not reopen and close the connection all the time.
That's right, and really the key here is to be able to do cost profiling, to take a look at your application and create the cost profile of your application, and then you can optimize based on that. And that's really the key here.
Okay, so let's look about cost profiling. Now, I hope that it will work because these are the first bits of a new tool, which is a cost profiler. The tool is switch to C. The tool it looks like the same like performance profiler, but instead of finding performance problems, it looks for cost. So we will start the profiling. And we will run a test console.
Two up, right here.
Let's start. Yeah. And it starts the Azure emulator. So we can look.
Nope.
No, I did shut down. Sorry about that. Let's do it again.
Do you want to start it before you shut it down? Before you?
Start profiling. Start profiling. Start new instance. Yes. Now I will not shut down. I will not shut it down. I will show it. So I deploy the application, and I want to cost profile the application. So I have a test client, and let's just create a page blob. So I press A, and it runs this test. And now I can see those places in the code that cost money, that made calls to the cloud, to cloud services, and cost money. If I double-click each of the lines, I can also see the total cost of this line. So I can cost optimize the application. I also can see the flow of the call and see where I spend most of the money in this flow. I can also give some prices or have the price model of my application usage.
So again, this is when you're using cloud. If this was, if you were using SAP or any other kind of system that that you get charged, or whatever is the system in your enterprise that you get charged access for, you can go and create the cost profile that is applicable to whatever the solution is that you're building. So that was about code, but there's a lot of stuff other than code. We need to think about the cost of data, connectivity, and security. And in terms of process, we need to think about the cost of dev and QA, as well as the cost of bugs. When you talk about the cost of data, obviously there's the data size. We talked about required fidelity when we saw that demo when we optimized the images. But there's also data retention policies. When you keep data, you got to pay to keep that data. In the cloud, it's very obvious, but it's the same thing running on your own data center. That's the cost of data. Think about that. There are all sorts of ways to optimize storage. I list here all sorts of data storage options in Azure, and for each one of them, there's a different consumption and pricing model. And the same thing might apply in your organization, whatever on-premises thing you have. So you need to select the right storage option for what it is that you need. Once again, a lot of guidance about how to optimize storage services, a lot of things to spark ideas in your head, things like computing data at the right time, batching operations to reduce storage transactions, etc. Other things, like protecting against data leaks. Data leaks are a very interesting phenomena. It is about losing a reference to a piece of data that you have. Now, if you're storing it in the cloud, or if you're storing it in your own database, once you lose a reference to it, it's going to stay there. And you're going to pay for it till the end of time. You're going to pay for that storage. In Azure, it's very immediate. But
so what you mean is that data leaks is like money leaks?
data leaks are just like money leaks. When you're leaking data, anything you leak, it's like anything you leak is going to cost you money. If you leak memory, if you leak storage data, right? If you leak network connections, if you leak handles, whatever it is that you're leaking, you're going to take resources and you're going to lose them. And as you lose resources, you got to replenish that. You got to bring other resources in their stead that are going to cost you money. There's some things that you need to avoid, like storing large binary data in SQL Azure. Actually, SQL Server has got this file stream thing that is very, very efficient for that. But if you just think about SQL Azure in the same way, that's a bad thing to do. Connectivity services are another thing that you need to think about and how you're going to optimize that. And connectivity requirements have two kind of requirements. They come from two sources. One is the architecture of the application. Right? This is how I architected the application. This is where communication happens. That's, if you want to change that, you need to change your architecture. But there are some things in there that are code artifacts or code idioms. And those things, like what we just showed you in that example, those can be addressed. So you need to understand the connectivity, consumption, and pricing models for your data center, or if you're running in the cloud, and think about that. There are many ways in which you can optimize connectivity. You can throttle communication. You can do some fan out for events. And if you're going across the network, then you might want to put the data next to or the thing consuming the data next to where the data is being stored. There are things you want to avoid, like retransmitting data over and over again. Why don't you just cache it, right? Or keeping connections open. And then there's the cost of development. So we talked about the cost of, those assets that you have, but then there's the cost of development. For the cost of development, you need to think about the cost of the development process. If you're doing unit tests, if you're doing continuous integration, every time you do something like that that needs to access a resource that you're paying for in a consumption-based model, every time you do that, you're going to be charged. You need to think about how much does a check-in cost. When you do a check-in, especially if you're doing continuous integration, how much does this check-in cost? When you think about QA, same kind of thoughts come to mind. There's the cost of testing. Whether you're doing manual testing, now we need to go and deploy an image, whether that's in the cloud or if you've got virtual machines for that. How much is a VM going to cost me if in a chargeback kind of model? So you need to think about the cost of that, but more so about the cost of load testing. Now I have the system. I want to go and put a heavy load on it. I'm going to have thousands or hundreds of thousands of machines simulated going and going against it. Well, it turns out that system automatically scales up. And as it automatically scales up, it's going to start consuming more resources. You need to think about that as well. You need to think about the cost of a full test pass. How much does it cost to do a test pass? And then, when you do that, then you need to think about, is this bug or is this change request that we put in at the last minute because it's, it's a showstopper, we can't ship with this thing. Then really? How much is it going to cost you to test that? How many people are going to be affected by this thing? What's the effect of fixing it versus not fixing it? Because everything costs. I have 2 examples for cost of bugs for my friends. Actually, 3 with the one you told me yesterday.
Yeah.
And I have a friend who had a little, they're both playing in Azure, just testing stuff out. He had a little bug. It only cost him $5. That's just one bug. Right? Think about how many bugs you have in your database, how many of them are going to have a cost associated with them, and for each one of them, how much is that cost going to be? So another friend of mine had a bug that this one cost him $495. Now take that, multiply this by 500 bugs. The numbers add up. So you need to think about the cost of bugs. And we already talked about leaks and how much leaks are going to cost you, right? But there's also things like instance crashing and recycling and things of that nature. As those things happen, you have bugs that cause your your website to crash and restart, and your app pool needs to grow. Or if you're running in Azure, your instances are crashing. Now, as they restart, they're not available. And so what needs to happen? You need to spin up more instances. You need to grow your web farm. You need to spin up more instances in Azure. And as you do that, those bugs are costing you money at runtime.
And you pay for the full hour.
And you pay for the full hour, that's correct. Right? And then there's this thing about consuming resources without making progress. If you're, that's another kind of a bug where I have a message coming into, say, on the message queue, right, MSMQ or MQ series or in the cloud, the messaging in the cloud, and I'm processing that message, and I'm not very resilient, and something in this message is wrong. So I can't make progress. It's what's called a poison message. So I read it, I can't do anything about it, I blow up, it's read under a transaction, goes back in the queue, the next person is going to read that, do some processing, can't do anything about that, message goes back in the queue until we realize it's a poison message. Well, I've just spent 5-10 times running a very heavy process to try to process something that cannot be processed. So what is the cost of that? Working without making progress. So we talked about dev, test, I want to talk about ops. When people talk about the cloud, they say, oh, ops is dead. Ops is dead and buried. It's not. I actually had a really interesting conversation just 2 days ago with an IT architect, and we were talking just about that, and we were in violent agreement on this thing. Operations is extremely important in a consumption-based model, whether that's in the cloud, the public cloud, private cloud, or if you're running VMs or whatever that is. Things like data backup. Okay, so if you're storing your information in Azure, it gets stored in 3 copies, right? Every time you write this, the call won't return back to you until this is safely written 3 times. Well, that's great. What about user errors? Right? Joe comes in the morning, and he wanted to delete, table temp, and instead of deleted the table customers. Oops, what now? Right? Windows Azure will happily delete it in 3 copies and get rid of everything that you wrote there, right? Data backup. And things like backing up blobs or other binary information that you have, not necessarily things that live outside of databases. So that's one thing that is still going to remain very important in the life of an operations person. It's not going to be something that, so the change in ops is very much, what they're going through right now is very much the industrial revolution of IT. When the Industrial Revolution came along, people were afraid, right? They said, we're going to lose our jobs. Our machines are taking our jobs. Turns out, we're all living actually quite a bit better, right? And this is what's happening now. As IT takes the next step, people are not going to be necessarily patching cables or installing machines or replacing broken hard drives anymore. They're going to be managing virtual infrastructures. And so they up-level the conversation. But there's still some fundamentals like data backup that are going to stay. And another really important thing in a consumption-based model is creating cost-effective data retention policies. You can't just say, oh, it's just data, we're just going to keep it there forever, because you are paying for it. So what is the correct data retention policy that I want to have? And then there's monitoring of resource consumption on a regular basis. This is not drop it in and there you go. Because if I outsourced my development, and let's say I'm writing an Azure app, and I outsource my development somewhere, and the developers that I've outsourced to, they spin instances up and down, and
open 10 connection to service
or open 10 connections to the service bus and leave them open, or 100, and I don't observe that on a regular basis, then I am losing money. This is not just about the money that I'm paying for developers' time, but there are other resources that are going to be consumed. So you got to monitor these things on a regular basis and be able to have insight into what's going on there. Now, we talked about cost orientation, and we talked about the important things about it. But there are other things, like every good thing, you can also overdo it. Okay? So I want to talk about not overdoing it. The first thing is shifting cost models. Right? You architect your solution for a particular cost model, and then the cost model changes. And your solution that was very cheap and lean now becomes not so cheap and lean.
Just think about migrating to the cloud. You develop your application to run in your own services on-premise, and now you move to the cloud. And now you pay by the hour, and you pay for connection and communication. So the same goes when you move from one cloud to another, or if your cloud provider will change the cost model. So you have to be very agile. You have to think about changes.
That's right. And if you do, so the general guidance there is to focus on the high-level models. If you do need to do something that is finely tuned to the cost model, encapsulate that. Make sure that it's not something that you will need to do a rehaul of your system if the cost model changes. And the next thing is about avoiding unnatural acts in the name of cost reduction. I already spoke about that a little bit. But it's about not creating overly complex solutions, things that are going to be so overwhelmingly complicated in the name of cost. Because once you do that, or on the other way, right, do something that is so bare bones that doesn't even give you the functionality that you need in the name of cost. The point is to create really cost-efficient applications and not do things that will result, for example, in unmaintainable code.
So if you follow the general rules of software architecture, and if you follow some of our recommendations here, you will probably go down with the right path.
Right. That's kind of the good news, right?
Yeah.
Yeah. So here's my statement again. And hopefully by now, if you didn't agree with it before, you agree with it now. And if you agreed with it before, you now have more reasons to even strongly believe in that. Is that not accounting for the cost implications of your architecture design and implementation will result in lower cost efficiency. So we're going to sum it up, and then we're going to open it for discussion. And we can go back to any of the slides and any of the topics if you want to talk about this more. But we talked about cost orientation being about maximizing the value of your investments. It's a quality attribute. It's not a constraint, because constraints, as we said, can be negotiated. It touches every aspect of the application lifecycle. And our message to you, our recommendation to you, is to integrate cost orientation into every single phase of your project and think about that holistically. We'll get to that later. Don't forget to fill out the evals. But before this, do we have any questions? Yes?
So if I understand you correctly, what you are suggesting is that let's say you're doing agile development, some sort of time-boxed iteration.
Right.
Really, you should apply this as part of your exit conditions or
Right.
something. To every iteration, take a look at that cost model.
Absolutely. You need to do that when you start. So when you plan your iteration, right? When you're planning, say, what are our cost goals? What are we not going to exceed, so that you have something to measure against at the end. And then at the end, you go back and we say, how did we do against that? In the same manner that you do this for any other aspect of your agile development.
But the problem with something like this is, unlike a use case where you can say, what you have to do for this piece of functionality, this is a more emergent property.
Right.
That really an architect or somebody who has a broader perspective has to take a look at.
Correct. Very correct. And the great thing about it, if you're doing agile, is that you can look at the cost change from iteration to iteration, and you can stop. And you can say, you know what, guys? This is going the wrong way. Whereas our cost is going to trending up with each iteration. If I project this forward in 3 iterations, we're not going to be cost viable anymore.
Really, what in some sense you're saying is, theoretically, every use case should have a cost associated.
Right.
If possible, yes.
But that's,
Right.
That's fine.
It's exactly. It's the pie in the sky. But it's a good thing. It's the good thing to aspire for. Right.
You can even create some sort of cost-oriented testing. If you can use the profiler and the output of the profiler, you can fail the test if this feature costs too much.
Right. But that's probably not something you can do on check-in. That's more like
No, it's more like acceptance test and later on. Right.
Yeah. That's right. I'm sorry, it was hard to hear.
I'm sorry, I was saying ultimately, if you know the cost of business transaction,
Right.
you have a better idea of whether you're making profit.
More than that. So the comment was, if you know the cost of a business transaction, you know if it makes, if it's fiscally viable, right? If you're making a profit or not. And that's actually a great thing. If you actually know that, if you can put a dollar amount on, this is how much it's going to take me to process that transaction, right? You can price your product appropriately. This is the shipping and handling. This is the handling part of the shipping and handling in our software industry, right? It helps you create the right financial models for your solutions. And so whether it's something that you roll the price down to your, to your whoever's consuming that service, whether that's internally or to external customers, or if you're providing a service inside of your organization and you're doing a chargeback model, you can now tell the other department, whenever you're doing this is how much it's going to cost you, right? It's 0.35 cents for every time you call me. So make good use of that. Yes?
To develop a cost profile, the way you described, what kind of skill sets are required? It's not just not developing an architect. You need a lot more information,
Right.
a lot more skills.
Right. It's like a new discipline.
It is a new discipline.
It is a new, yeah.
It is something that ties together. So think about, that's the business analyst, is the person you're looking for. That's the third.
But it's not just him, because if I have a bug and this is why this is cost so much, then it's a senior developer or the architect that has to look inside the code and see why I pay so much for this request. Maybe I open and close connection all the time or these kind of things. So it's many different responsibilities, many different people.
But the person I would hold responsible for that is the architect, because the role of the architect
Probably.
is to be the person who stands between the business and the technology. Right? That's the role of the architect. So the architect needs to stand there and say, yes, it makes sense, or no, it doesn't. Go change that, or go change that. Go back to the business and telling them, look, you asked us for this thing, you gave us this budget, it's not doable. Let's work on it. Any other questions?
At the beginning of your presentation, you claimed a 10% to 90%
Right.
operational ratio. Taking a cost-oriented approach, do you expect that ratio would change?
I certainly hope so. There are aspects of it that cannot change. There are aspects of it that cannot change. But in fact, this is really funny. Can we go back to that first slide? Or it's the second slide, I think.
Right. No. I can spend money again.
Thank you. All right. So if we go back to this slide, we see something really interesting. If this is going to be a fixed cost, right? If this is going to be a fixed cost, and I'm going to reduce that, so if you think about it, this divided by that, actually, my operation costs are going to go high. The ratio is going to go higher because my runtime costs are going to be lower. Do you understand what I mean? So, but overall, the amount of money that I'm spending, so if we look at the ratio, it might not make sense, but overall, I'm going to cut the amount of money that I'm going to be spending on the project.
So you might shift at 20% of your investment in development because your cost per development is better profit is higher. But the overall cost.
Right, because when I write software, typically, there are several categories of applications. They're the one-shots, right? I'm going to write this app and run it once. Okay, I got this big wad of data that I need to go and process, and I'm going to write this thing, and I'm going to run it on HPC, and it's going to take this thing, run an algorithm against it, and give me an analysis. Okay, those things have a cost associated with them. If you write them incorrectly, instead of using 10 virtual machines, they'll use 50. That's bad, but it's manageable, right? The other kind of apps are those that run for a particular amount of time, a seasonal app, right? I got this promotion, I got this sale going on, I got something that is limited in time. Those things have a bigger effect on the runtime cost because now I'm going to run this thing for 3 months, right? And then there are those apps that most of the apps fall into this category, which are like long-running apps. I'm building this app, it's going to run for 3-5 years. We're going to version it, we're going to update that. But those applications, their runtime costs are going to be the highest. Right? The ratio, right? The ratio, because they're going to be out there and running for a long time. So if you can save 10% on the runtime cost for this thing, and this thing costs $300 a month to run, that's $30 that you saved. But it's $30 this month, $30 next month. Take that going forward. And maybe it's thousands, right? And then take that going forward, multiply by 12, by 5, and you get the scale now. And so yes, I might have invested a little bit more, but I got something better. Now, what we hope is that over time, cost orientation would become a natural part of the development process, so it would not add anything. Just like security today had been integrated into something that is more part of the development process, and people that do practice this SDL, software development lifecycle, and the security applications of that. People that do practice that, they don't add anything extra. It's just part of the process. When you estimate the cost, it's just it. And nobody thinks about not doing security, right? Nobody thinks, you know what? We're going to save money. Let's not do security, right? Nobody thinks that way. And in the same manner, our hope is that in a few years, nobody's going to think about, we're not going to do cost analysis. We're just going to go. It sounds ridiculous, right? The way I say it now. Because, we've been here, we've been talking about this for an hour now. You kind of got it. But most of the world doesn't think that way still. And we hope to change that. Yes?
There are two ways of looking at cost. One way is I have $100 to go build the best application that you can
Right.
build. Or
Right.
build the best application and figure out what it costs and then figure out how to reduce the cost.
Correct.
So for first-time applications that you're building from scratch, V1, you can't say I have only $100 to go build this. You want to actually figure out what you can build the best application, then figure out how to reduce the cost appropriately. Of course, you think about all this, but this should not be the high order thing in the first time.
It may or may not. It may or may not. Actually, in both situations, both of you are starting with a fixed budget, or if you're starting with an open-ended budget, which hardly ever happens. But let's say that you get assigned a task. I need you to build me this solution. And go figure out how much it's going to cost. Right? That's going to be a second scenario, if I understood it correctly. Is that
But-
more or less?
But you do the same. But you do the same for building the application, because you have the budget for building the application itself. So now you have to think not just about building the application, but also for the operation of the application. So anyway, you have to think about cost upfront.
What was?
Not exactly.
Okay.
Because any of the, any starting, I'm starting a new project.
Mm-hmm.
I'm going to venture capitalist building
Mm-hmm.
and ask for money.
Right.
But before I ask, I will do a prototype. I will spend months
Right.
or even years building that.
Right.
When I'm doing that, I'm not actually thinking about cost a whole lot. I'm thinking about what is the right application that I want to build. What is the killer application? What is the killer feature that nobody can easily
Absolutely correct. Absolutely correct. What I'm saying is that at the same time you're thinking about that, about your functional requirements, because that's what you're talking to me about, the killer features. What are the things that without them, the product is not going to be a winner? Or won't make a difference? When you think about that, I actually highly urge you to think about the cost implications of those things. Because when you go to the venture capitalist, is going to ask you, okay, well, how much are you going to charge for your service?
Absolutely. By the time I go there, I would have figured that out. Right? When I'm
So why wait? Why wait? Why wait until the end? It's just like doing security at the end versus doing security from the beginning. And that's the point. It's a new concept. It's something that is not, people might argue with, and people might have a.
not arguing. It's like creating the best burger, for example. The ingredients that you want to put in it, you don't want to actually, you want to experiment. You want to put
So for prototype,
ingredients that you don't usually put. You don't want to make a regular burger. You want to make an exotic burger.
Right.
So you will think about ingredients that will figure out like four different.
Right. So would you try gold in your burger? It's exotic. Oh, it is actually. It goes through your system. They got the gold plated, silver too. In India, they have those silver, right? They're delicious. I don't know what they did to your body, but it worked. So would you put silver in your burgers? Right? So that's my point. That's my point exactly. You can go, yeah, let's experiment with exotic stuff in our burger. Let's put gold and silver inside of it. It's going to be a hit. Who's not going to want to taste a gold burger, right? but think about it, right? Then you go, well, actually, I don't know if that can be a viable business. And that's what we're talking about. Okay? Now, there are things, yes, you will do, you will experiment, you will try. You know what? Let me see if the system scales. I'm going to spin up, I'm building this cloud computing application. I'm going to spin up 100 instances. I want to see if it scales. Fine. You're doing that with cost in mind. I'm going to say, okay, well, I'm going to do that. I'm going to spin them up, but I'm going to run them for an hour and shut them down. Right? And I know exactly how much that's going to cost me. So let me prepare before I do that to make sure that when I do spin them up, that I do it properly, that I'm ready, that I have everything ready to go. And okay, let's spin them up. All right, oh, I forgot to write the test. Let me just write the little thing here, and you know what I mean? You think about the cost at every single stage when you're experimenting, when you're implementing, when you're testing, when you're architecting. Is that a question? Oh, did I answer your question? Thank you.
So, if I'm a mature business, say Amazon, and I can see spending a lot of effort in optimizing the cost of everything, making images smaller, all the, the 100 things that you mentioned. If I'm a new business, I'm a startup, I don't know if I'm successful yet, I can see there being a downside to cost optimizing before I even know that there's business.
What's the downside?
Spending too much time and effort.
Time, and I might cost optimize the heck out of my first release of my product that nobody actually uses, so the effort going into cost optimization.
Right.
Fair enough.
So I'm just wondering how you think about the cost of cost optimization.
So
Yeah,
it's
the
a
second
great
level,
it's a great question. So let's say that the cost was zero. Let's say that the cost of cost optimization. Let's say that you had a tool, right, like that image optimization thing. It would just run and it just compresses, lossless compression, just makes it smaller. Are you going to not do that? Is there any reason for you to say, no, I want to pay more? There isn't any, right? There are things that if it's easy enough, then you're just going to just do. So the hope is that once people start thinking about that, once people start doing stuff about that, we will have a set of tools, a set of methodologies, a set of ways to deal with those things so that cost orientation doesn't cost you much. Right? Yes, doing stuff right costs you more, but the hope is that the money that you're going to be spending is going to be less, a lot less, than the money that you're going to be saving.
If you could make it, if we as an industry could make it like a compiler optimization.
Yeah. Exactly. Exactly. Just think about it. Do you remember back when the compiler built this code and then people used to go and hack at the assembly to make it faster, and then they said, oh yeah, let's do, loop unrolling. That actually might be, let's build this into the compiler. And the infrastructure that we're using had improved over time to be able to do that. And so if we got the right, not just tools and technologies, but also methodologies and systems to deal with those things, then cost is going to be something that we can manage a lot better.
The example that you showed with the App Fabric service bus with
Yeah.
Yeah.
connections inadvertently, that's probably something that could be detected with static code analysis.
Right.
Yeah.
Nobody has it, I'm aware of.
Right.
Yeah. Exactly.
But I think some of that is slightly misleading because some of these cost considerations are emergent. So you really have to divide between local and global optimization.
Perfect.
Right.
Absolutely. And if I go back to, I don't know what slide that is, but
Just look at the slides.
no. I got it. That's this slide. That's that. Don't over-optimize right now. Everything, the cost models are emerging. We're just starting out. Things might change. But also, in established cost models, right, somebody might come and say, hey, I found a better way to do this. And I can offer it to you cheaper. And now all this thing that you used to work around this thing that was a little bit expensive, and you worked around it in a really funky way to get to that other thing, now that becomes cheap, and just go through. Wouldn't that be great? How are we doing on time?
It's up.
We're out of time. All right. Oh, is this the line timer? I don't know. Anyways, thank you very much. Thank you so much for coming. Thank you for being part of that. Don't forget to fill out your evals. They're very important. If you have any comments, anything you want to tell us, come talk to us here. Come talk to us at our booth. Leave comments on the feedback form or whatever that is that you want to say. Thank you again so much.